Under drain systems, when you have horizontal pipes in your rain garden, what we have found over the years, speed infiltration up, but they also can lead to nitrification. Because there is an ideal infiltration rate which can vary based on your soil composition. General idea that with the soil standards in the state right now, it's around 2 inches an hour. With 2 inches per hour drainage rate, you will get very effective pollution removal and still fast enough drainage so that your rain garden drains 24 to 72 hours max if you designed it with the parameters back. So having horizontal under drains in them, speeding water movement out of it. If you have water coming in from freshly fertilized lawns or from a street that's really heavily polluted, you will have pollution leave that side through the water, through the under drains. So with Derek from the Snohomish Conservation District, he and I came up with this vertical under drain design, and that's now actually accepted in Snohomish County as a standard design. And we had to do something because we have so much clay. You see this excavation. That's almost vertical wall, right? And it's not going anywhere because it's so clayey. That's what we have to deal with. But a lot of parts of the world have that. So this is a very simple system. It's a vertical under drain overflow control structure. You get a septic pipe, usually 18 inches is good, but that's your minimum also. We don't recommend anything smaller than that. And you run that pipe all across the section of your rain garden. You have to dig it deeper because you have to hold it in the ground. So if you have a rain garden, like in this case, these are 6 foot deep because of the clay content and the amount of water that we are handling in there. The pipe actually goes to 9 feet, so it's 3 foot in ground, solid standing. And then you drill holes into this septic pipe. It's as simple as it gets. If somebody wants to start a manufacturing company, you probably will make money with this. You drill 1/8 of an inch size holes into that pipe, a lot of it, so that the section that will be in the backfill is all poked through from every angle. And then you cover it with a rock blanket. So now you have rounded drain rock, preferably, that's covering it to filter sediment out, directly hitting it. You put a pipe in it for the overflow. In this case, it goes into the city sewer. That is based on the septic system idea. It's a 90-degree pipe so that you're capturing from below the debris. You put a gate valve on there so you can turn it on or off. If you have an opportunity, you have another overflow for emergency. It's always a good idea to have backup systems, and I'm sure you agree with that because you're engineers. That's something that I have to explain to other horticulturists, why you need to have 5 doors on every room. So you have a backup system, and then as your rain garden is filling up, this under drain eventually filling up vertically with it. You got a lot of void space in this pipe. You have the overflow backup, but now your water has time to settle out sediment and to sit within the soil. You are effectively slowing infiltration, even with having an under drain that's speeding things up to a level that removes pollution. Over here, that guy in the hole is 6.5 foot. It's a really big hole. The pipe that they are holding, if we had a darker room, you could see it clear. It's actually a valve. It's an injection valve. It goes 65 feet deep into the ground, into the aquifer below, where as we were digging, we found bleach sand. The reason was, this area was almost standing water every time we dug a test hole. We have a similar overflow control structure in this design, just like that, but it's connected into this injection valve. Because of the control structure, we had, in the past 3 years, we had one overflow event when the rain garden was still brand new. That was it. We managed the clay to actually absorb that water. This is a very good functioning system. So we went back and forth on this to patent it or not. We decided that we'd rather teach it to people because we would like to have functioning systems rather than have a patent that somebody will come in and do a yellow pipe and now, you know, it's a different design anyway. So here you go. You can make whatever you want with it. This project is up in Everett next to the Providence Hospital. We have 7 rain gardens, all of them are different, and it's a pilot project. The reason that it happened is that when the hospital was built, same story, brand new hospital, they connected all the runoff and their entire sewer system, and if you can imagine, a hospital has a few bathrooms. The entire sewer system to the existing sewer system the city had. And that was already maxed out before the hospital was built. So first winter comes, we have our traditional northwest storms, 3 inches in a day, oopsie. We had entire neighborhoods with backing up toilets in the basement, standing sewer everywhere. The neighborhood sued the city. And so the city was calculating back and forth and talking to a lot of consultants, and they came up with the idea that the most cost-effective way to address this is building rain gardens. Now, Providence Hospital, you can Google it on map and see how big that is. And how many floors it has. How many toilets you think that has, and bathrooms and showers. And we effectively seized all flooding in the entire affected neighborhood with 7 rain gardens. This is how effective rain gardens really are. If you think about it, it's an amazing. With just 7 of them, infiltrating so much water. And it's on almost solid clay to top it. So these are, in fact, the 2 gardens that are just after finish. It's planted with volunteer event. So you don't see those pipes. They are not an eyesore. This is looking really attractive. And yet, it's quite a designed and engineered system. And it's a rain garden. It's not even a big deal, right? So then, locating, sizing, we're going to go through these a little bit. And I have to speed things up unless you want to take more time. I don't know if all of you will leave at 5 or you plan on staying for the whole event until later. Are you planning to stay? Okay, so then I'm just going to sort of going through this because there's a lot to cover. And these are all important details, I think. But again, if you have questions, please speak up as I'm talking.
Should we take like a 2-3 minute break or something before?
Do you want to take a break right now? Because we're going to, this is the next chapter. You want to take a little bit? Yeah, actually, let's do that. And I better turn off the phone. They probably want to know if I survive my trip. Or not. Okay. I wouldn't mind to drink something. Is there a fountain? Okay. All right. So we changed the stage, the background is a little different, scene. We are designing. So you're sitting at your drawing table now. Or not,
I see.
because you first have to locate your rain garden. Could you introduce yourself a little bit?
My name's Saeed,
Uh-huh,
and I'm Sabi's best friend.
uh-huh.
And so basically, I'm just here to learn as much as I can.
Okay, so you're a civil engineer. Do you have a
Civil
stormwater understanding? A little bit of background in that?
I do structures, so
Structures,
I'm
okay.
trying to learn.
That's really good too, because the structures you design will ultimately feed into a rain garden, hopefully anywhere around the globe.
All right, thank you.
So locating a rain garden. You are going to get a phone call. I would like a rain garden. You're thinking they want a stormwater facility. And you start the communication, you start talking. They have a little bit of a slope. Okay, that's flag number 1. They have standing water. Red flag number 2. They have a small yard. Red flag number 3. Well, they don't exactly know where their utilities are, but the last time her husband planted a tree, they had to call the gas company. Red flag number 4. And often, when they dig little holes, they find standing water. Red flag number 5. But because she's not a civil engineer, you're gonna go out there anyway. Lesson number 1, please, all engineers, please go out to the site. If you live in New York and you get a call from Everett, Washington, refer it to somebody else. One of the biggest mistakes I see, I do a lot of slope restoration too, that's one of the niches that I got into over the years, is I work with geotech engineers and civil engineers who are in their offices and never saw the site. And I go out to the site and I look at their drawing and yeah, the grades are the same, yes, it's a survey drawing based map. But obviously they had no idea about the rest of it. It's very important that you document things in real life. If you have to take an airplane, have them pay for it, but go and see it. Because sight unseen, your design is basically a dice roll. It's just a luck if it doesn't fail. So, when you go out to the site to investigate, you will want to see how steep of a slope that is. If it is steeper than 15%, then even as a civil engineer, you do want to talk to a geotech engineer friend. So make sure you have friends. You want to see their opinion, because it could cause a slide if you infiltrate more water into an already unstable slope. Another thing that happens, and we people who live close to the beaches, we know very well that water ultimately wants to go to the beaches. So if you have a bluff and you're infiltrating water in rain gardens or bioretention cells uphill, that water eventually will surface somewhere on that bluff. It wants to find the beach. And if we infiltrate too much water, then this little seepage will become a burst, and you will have soil sitting on train tracks. This happens too at times. So make sure that you really investigate, not just that site where she lives, but the entire area. Do a little research if you're not familiar with the story, with the geological history, the development history. What was there before? I will talk about a thing that happened in Seattle and was a really big failure because they did not ask the right questions. They could have avoided the whole thing. We will get to that. Do the soil test. We are going to talk about that. do an actual soil test. If you have recordings somewhere in a library about that particular parcel, that's great. You're gonna do your own soil test. Again, you want to have a hands-on experience with that site, so that when you stamp your drawing, you can sleep well. If you didn't do this, it can come back and haunt you. It can become a liability. Rain gardens are stormwater facilities. This is not landscaping. You're not just going to plant a dozen of plants. You're moving water into the ground, and if you don't do it right, it can become a problem. So always, always do your soil test. How far you have to be from a structure is number one, regulated. So any jurisdiction has a regulation about water in the soil, how far it has to be from structures. If the jurisdiction doesn't have it, because yes, they're supposed to have it, but they don't always have it, and if they have it, they don't always know it. I also teach codes and regulations, so don't get me started on that one. Then make sure you use rule of thumb information. Generally, your minimum distance for a rain garden to be from a structure is 10 feet. That's really a general number, but it may be different based on jurisdiction, or talk to your geotech engineer friend and see what they recommend. I don't recommend infiltrating water on top of utilities. And if you have a septic system, your drain field and rain garden will make both of them fail. And it will be a very stinky mess every time it rains. So don't put a rain garden on a septic system. Drain field. Right-of-way, ROW, is another thing. Right-of-ways are strongly regulated in jurisdictions, so make sure that you double check what the codes are. And back to water table. We are infiltrating water. If you dig a hole and it has standing water, start thinking. It may not be the best location, or you have to do some other things. If you have a Providence hospital next door, you may have to do an injection now. So as you're testing the soil, you will come across all kinds of things in a hole. You want to see clay, sand, silt percentages. If you can create a little figurine, you may want to open a pottery shop, not necessarily a rain garden. So just keep that in mind. But it may not be totally eliminating your rain garden idea either, because if you can actually do a vertical underdrain, you can maybe have something that works well. Ribbon test is another easy soil test. It gives you, again, a feel of how much clay you really have in that soil. With ribbon test and the little sculpture test, that's what you're looking for. You have a lot of sand in it or not. Jar test is a very, very simple soil test. If you haven't done one, look it up on YouTube and please do one. It will actually help you place your soil on the soil triangle, which again is one of the most simplest systems ever. It gives you how much percentage of sand, soil, and silt you have. It's that easy. Soils make or break not only rain gardens, but low impact development often. Low impact development works with soils and vegetation. So knowing what soils you have will drive your low impact development solution. And rain gardens are just one tool in that really big toolbox. So you may not be able to use that, but there are other things. Very important to know that you want to preserve the life in that soil, and you want to also increase the life in that soil. So if you find critters in there, that's a good thing. If you have worms in there, that's an awesome thing. And you also have to remember that saturated soils are not going to absorb any more water. They reached the full capacity, that's it. So if you have an area that actually has standing water there in the summer, that's a saturated soil. You can build a wetland there, and those are really fun projects. but it will not become a good stormwater facility for drainage, infiltration. It can still remove pollution, wetlands do that. So very basic, dig a hole thing. Do the soil test. At least 24 inches deep. How deep a rain garden has to be? Most of the time, and in this rain garden handbook, you will see that you want to create usually about a 30-inch deep hole. The reason behind that number is that 18 inches of soil mix actually creates a very good environment so that most of the bacteria is removed from your pollution. And that's at 18 inches. What they have found over the years is that we used to start at 12 inches. That was the recommended depth. That pollution removal for bacteria especially, it builds up slowly, and so it goes up and it plateaus at 18 inches. It doesn't change that much for the bacterial levels after 18 inches. It does increase a little bit if you go way deeper, but 18 inches will give you that. Then you want to leave 3 inches in that rain garden for your woody mulch. We talked about it in the beginning that forests have the duff layer. Debris, branches, leaves. That's your woody mulch. You want to have about 3 inches of that. So that's 21 inches. And then an ideal ponding depth that will still be safe, even if people leave their 1-month-old babies outside, because you will have people complain about any standing water when it comes to kids. Nobody died drowning in a rain garden yet, as far as we know, just so that you have that argument too. But we hear all kinds of things. So safe depth is 6 inches. That's pretty standard. So then now you're up to 27 inches, and then you want to have at least 3 inches of freeboard. So that's where the 30 inches comes from. So you want to dig at least 24, preferably 30 or 36 inches. As you dig that hole, you can make incredible decisions because it's a fun activity. If you can dig that hole in 15 minutes, that's no problem. Your soil is at green, you can hand dig everything. If it takes you 3 days, you really want to reconsider that rain garden and how you're going to build it. Because you're in hard pan or in granite, and those don't drain very well. So then you can follow the instructions in the rain garden handbook. If you actually want to follow on larger scale, then do the low impact development handbook that came out last year. And if you are in a project that is considered minimum requirement 1 to 5, you will have to follow the stormwater manual for Washington State in this state, but you have to follow whatever the regulation is in whatever state you are in ultimately. To do the testing. So, if you can just do the testing yourself, I strongly recommend that you have 2 things in hand. One is a shovel or a post hole digger that will help your work. The other thing is a pipe, because you are ultimately interested in vertical infiltration, not side seepage. In heavy rain times, when the soil is saturated, you only have gravity. Everything else is saturated. If you design that rain garden for infiltration in all directions, but you get to that saturated point that it's only gravity, you under-designed your rain garden and you're going to have a lot of overflow. So you need to have a pipe that's big enough that you can see into it. You mark inches in it. You put the water into the pipe and see how long it takes for the soil to dry it down. And you do that several times. I recommend that we do soil testing in very rainy conditions. Because you're building a stormwater facility, this is not a project that you get a phone call on Friday and a week later you have an excavator going out to the site and building the project. You need to take your time. When I get calls, it usually happens the next year. Because I take this time, starting pretty soon here, to test the soil. And I test throughout the winter. I sometimes, if I'm not sure, have test holes open all around the place. And I keep going back there. When you gathered your information, then you can do your design. Take your time. If you have to, because you're under pressure for whatever reason and you cannot say no, those happen too. If you have to test during dry season, you have to saturate that soil. And that means water trucks sometimes. And if you're bidding those jobs, because you work on your own, you better calculate your time and water truck in there. Because you're gonna eat that job otherwise. So you calculated the drainage rate. In the state of Washington, if you have half an inch an hour or more, your soil is draining well. If you have less than that, your soil is draining poorly. I can think of another place around the world where that would be the decision maker, because half an inch is actually a very slow drainage rate. Most of the places drain a lot better. But we have glacier till, we have glacier compacted soils, we have lots of hard pan. So if we get half an inch, we are happy. And from a rain garden standpoint, in the state of Washington, we managed to make them work. And so now the rest of the world is looking at these systems because it's so important that they work in slowly draining soils. They can do it anywhere else. Then you start looking at contributing areas, which is not just your roof and not just your driveway and not just your street, but it's also the lawn. If you have lawn, that's a contributing area. Very important. Play areas are contributing areas where kids walk around a lot. These are very simple calculations and you can follow them in the book. This is the old system. If you still have the old handbook in hand, make sure that that refers to 12 inches. Now it's 18. But you can see that actually sizing a rain garden to the contributing area is really pretty simple. And this was done for homeowners. If a homeowner can do it, so can we, right? So if you see it, 10% in well-draining soil of the contributing area gives you 99% infiltration rate. If you remember the image with the forest, those dips are not very big, and they work very well. You don't have a flood at the other end of the woods going into the lake. It's all in the ground. It infiltrated. If your site, when you go out to see it, looks like this and it's summertime, that's a potential wetland site. But if it looks like this in the winter, it could just mean that it's compacted soils. And a rain garden will actually remedy the situation. And that's actually what happened here. This used to be woods, they scraped it, built the house, and now it doesn't rain. Sometimes you can build more than one. If you have sites where you can't put all of that 10 to 20% area into one location, don't be afraid and divide it up. You will be creating a really good ecosystem that functions well. You can have one rain garden on every single damn spot if that's what you want to do. You know how to calculate the slope. So, where to place a rain garden? You never want to put a pump into it. It's not a water feature and it's not a landscaping feature. So you have to make sure that your slopes are actually working for you and not against you. And again, with the slopes, you don't want to end the water in somebody else's basement. So it has to still be manageable staying on the side. You want to put it in a place where it improves aesthetics, it doesn't block view, or if it has the potential, then you really need to know the plants on how you're going to match the root system with whatever is above ground. And again, you can have more than one. So we calculated this. These actually, there are now with the force, for Western Washington especially, we have a very good hydrological modeling program. And the fourth edition has rain garden sizing in it. So it's just a matter of putting in your contributing area, where you're at, what surface you are getting the water from, so that you can put the coefficient in there automatically. It will spit out the size of your rain garden. Great. Are you done engineering? In the past, yes, you would be, but no, because this is a rain garden. So you either know some plant material material already, or you call on your horticulturist and keep going with your design. If you have slopes, you can terrace. There are more options nowadays than just a giant berm. You can actually terrace infiltration into the whole system. It's really fun. You can have a lot of good with that. This is berm and terracing. Pretty big system. This is at the UW in Tacoma. Very fun. Small. See how tiny these are? And yet they take a lot of runoff from an entire parking lot and infiltrate it. Here is some terrace systems. That rain garden there is actually a container rain garden right here with a lined system. So plant material is absorbing that water and pumping it right out of the soil. It overflows more often than not, yes, but still the water that gets out of there is cleaner than if it would be without that rain garden. The other side is compost sock technology. I strongly recommend it. Filtrex company makes compost socks. We'll talk about that a little bit more. They do training for design and installation. You have to pay for it. It's a certification that you can get out separately from your other degrees. But very useful material all around the world now. These are looked at to help with slopes, with bioretention, with pollution mitigation for industrial settings, as well as runoff management. Easy to do, and when you put them in, these will not require an infrastructure because you can put them in from far, blowing them into place. So this is something that you have to sort of understand. This is a very simple installation, but a lot of things can go wrong with that. Because it's so simple, and because we are in such dire situation regarding our stormwater and natural waterways, we actually encouraging homeowners and private individuals who are not engineers and not landscape designers and not even landscapers to design and build these small systems as much as possible. Around the Puget Sound, we have events for the public, and our goal is to have 12,000 rain gardens in place by 2016. Because the Puget Sound is in so much trouble. We now have limitations of how much per month, how many pounds of fish a person should be eating out of Puget Sound. Because if you have more than that, you may end up with some toxic buildup in your body. We really need to do this. But as an engineer, you have to think about all those things that could go wrong with the installation. So, yes, you want to excavate, you want to set your soil maybe aside. We actually have soil design systems where you don't bring in a bioretention soil but use the native soil in place. If the soil is somewhat decent and it's not on a slope and it's not in clay, homeowners can reuse their soil amended heavily with compost to create a rain garden, and it will still work. At Edmonds Community College, we had done 4 testing plots, and all of our amended soil tests are working very well, just the same as bioretention soil. Sometimes you will not get the same pollution removal rates, but it's better than nothing. So if they don't have the fund for bioretention soil, you can use the soil. You want to refill with compost amended soil, never just the native soil. How is that compost made? So compost and compost is not the same. When you think of compost, you probably have seen piles of leaves and clippings and grass clippings in a pile, aging, breaking down, turning into soil-like material, humus. You may already have a compost bin. You may have a verma compost bin that has worms in it. Not everything will give you the same result. So, the compost that is specified for rain gardens in this state, and it's a good idea to use it globally like that, is heat treated. it doesn't take 6 months to a year to break down. It breaks down usually within 56 days because it is kept at a certain temperature, 170 degrees usually, anywhere from 140 to 170. And it's kept at that temperature for at least 28 days, and it's monitored by a computer, and if it starts dropping, then air is coming into it, so the heat is increasing in it. If it exceeds that temperature, then it's cool. And the reason for it is we don't want to sterilize it. We still need microorganisms in it. We don't want to kill everything, but we want to create an environment in there that breaks pesticides down in that compost, because you don't know where the material came from. It actually breaks down pathogens, disables bacteria and viruses, so that you're not introducing a problem into your systems where you use that compost. There are more and more compost facilities in our area in the US that create that. A German company actually came up with a very good computerized system, and companies have purchased that method. The compost has to be either yard waste based or food waste based, but never manure based for low impact development solutions. So far, these are specifications in the state. There are experiments now, and I'm sure you've seen them, with humanure, Tegro, that's also that material broken down, and even animal waste and carcasses broken down in compost and so forth. There are tests with biochar and fungal material, but they are not standardized yet. They are experiments. So we may find that under certain conditions they work well, but they may not. So far what we had seen, for example, with manure-based compost is that salt levels in those composts are often high. And when you introduce salt levels into a rain garden or a green roof setting, that compost is in high volume, 40% often. And it will actually disable the plants because of the salts from taking water up. So standing water in the rain garden and your plants are not able to take the water up. They die. Other times with manure you have seeds that didn't break down all the way in the manure, and so you can have weedy vegetation coming up in these areas. That's why we right now do not recommend manure. With humanure, there are still a lot of things to investigate. Number one is how pharmaceuticals break down or not, and what happens with that, and how mobile those are in a rain garden or green roof setting, and what happens down the road. There are some very good systems that are approved for food growing, such as Tegro, and that's where the experiments are using material from. So keep this in mind as you are describing your specified soils. You can always check with your soil suppliers. When you start designing these systems, you will actually have some contacts. You will have soil suppliers in your area where you will specify material for your job, right? So you need to know what they have. And you have to keep up to date with all of those standards, and you can actually then look at variations. The bottom has to be flat. It's so easy. It's such a simple step. And it's often forgotten because most of the time sides are sloped. What happens again, it's a big bowl. You built a bowl. If you tilt it, water will be always on the lower end. Money and effort is wasted. You are not using the entire bottom. And another thing, you designed that system for the contributing area with that bottom in mind. But if it's not level, you only have a percentage of that. So you could have an actual failure having more overflow than design. These are very basic, code-driven. Most of the time in the US, right now, 15% or steeper slope will require a geotech, at least a phone call. If you work for a firm, they probably have one right in the other room. Now, burns are important. This is actually a bog rain garden. Let's talk about that a little bit. Another thing that we had experimented with the stewardship partners and the conservation districts, both the King and Snohomish County, is bog rain gardens. These rain gardens will drain a little bit slower, usually 72 hours rather than 24 hours. So they will have standing water more often. They still will drain away fast enough for mosquitoes not to develop unless we have a climate change event. And there is the trick. This is also why plants are so important. Florida, for example, is dealing with this problem. Their rainy season is in the summer. So mosquitoes usually need 5 days or more to lay their eggs and hatch. If we start to have heavy rains and we are in slowly infiltrating soils, then you could have a scenario with climate change, even here in the Northwest, but Florida certainly, where you have rainfall every second day. Enough for you to create ponding. Yes, when the rains do stop, your infiltration kicks in and the water will go away. 24 hours or less, 72 hours if it's a bog garden. However, if you have that ongoing ponding happening and you have the right temperatures, and if you did not create a habitat for predators of mosquitoes, you are going to have a mosquito infestation. You could have that even with a 24-hour draining perfect rain garden system. So you have to have your habitat in place. It's not enough to have a good shape, a good overflow, a good soil mixture prescribed. You have to have the habitat. What do you create habitat with for predators? Vegetation, rock placement. What are eating mosquitoes? One thing is frogs, newts, salamanders, lizards. They are the first. Dragonflies, bats, birds. So you've got to have that habitat piece down. As far as the danger of mosquito, if you design your rain garden well, it won't give you the mosquito because it's going to be eaten before it can say hello. But if you have a blue tarp somewhere in a backyard, rain falls on that, it has some depths, nobody pays attention, there is no frog living around it, you will have mosquitoes from there. So rain gardens, if they are designed well, actually are a lot safer than forgotten wooden piles or whatever you covered with that blue tarp. Outdoor kitchen. Here is compost sock being blown in. This is a long tube, this is the 18-inch safety sock. You can see how easy it is. We just built a rain garden cell in a terraced system with that. The beauty of it is that you can design the soil that goes into it. You can specify what you want to see in it. You can inoculate it with seeds, you can inoculate it with mycelium. It will filter the water because it lets the water through. Things can take root in it. You can build retaining walls with this stuff that are just the same as keystone walls, but vegetated. Nicer, better for everybody. Habitat, stormwater, you name it. Here is the Seattle Street that if you haven't been to yet, I strongly recommend it. It's in the Broadview neighborhood. It's the C Street project. These are hugely over-designed rain gardens. It's 2001, so deep and large and just when you're just incredible. It's just beers and it's fantastic, good looking, never overflows. It works like a charm. Yep.
On that previous picture, you had the white pipes
Yep.
below, right there on the left.
That's overflow from one cell to the other.
Where does that go? Is it just?
Into another cell down here.
Oh, okay.
So this one here is behind this, but here is our overflow from here to now. And then they all go into this lower cell. It was a sloped front yard. We wanted to terrace it rather than building a giant berm at the bottom. You know, you can just sort of like, as you're designing, you can create function and aesthetics at the same time. So it's very important that you go and observe installation as an engineer, and you also go and sign off on that job, or you send your best guy out to the site. Because when he and she goes out there are some things to look for. Is the inflow higher than the overflow? Because otherwise you may end up with a backing up system. We can design with lower inflow and higher overflow, but you know that that will take a separate design. So those are things that you want to double check, because not all installers are made the same and they may not understand this, especially if it's homeowner install. Another thing to watch out for, and I've seen it work the other way before, that inflows are larger volume of waters than overflow. If you have it going the other way, it's not a good thing. So these are just, you're gonna pay high rates of insurance. You want to make sure that there is less exposure to that for you. So with overflows, you want to create a predictable path for the water when your rain garden is saturated. Again, it's a stormwater facility. You need to know where the water goes when things are at full capacity and beyond. There are regulations where you can put overflows. Depending, actually in Seattle, depending on what project you're under, and this is where you really have to understand code when you work with jurisdictions, it's regulated that some of those projects, for example, if you are designing for a rain-wise project in the city of Seattle, some of those projects can only drain out to an alley if they are in the backyard. So you have to understand how to get to that point. And sometimes it's not doable. Sometimes you just can't do it, can't manage it. Sorry. Soil is perfect, the site is perfect. You cannot provide the overflow the way it's prescribed, and it will kill your project. Now you have to have another idea with LID. What are you going to do with that stormwater? How are you going to solve it? And we're going to talk about some other potentials too. So as you're moving water in, you can have pipes moving the water in, you can have a swale that actually is flowing, you can have infiltrating swale, or just a conveyor swale. You have to have a flow control in it if it's really long and if it's a steep flow. So think about those things. And the same thing for overflow. Sometimes your overflow runs pretty long and you need to think about how it's going to be controlled. Erosion control is a must. Very simple erosion control in a rain garden is called rock. Flow control in a rain garden can be called a log. Simple things. It doesn't have to be some incredibly complicated solution, but it has to be there. Here you see the elevations for inflow and overflow. Inflow doesn't have to be an eyesore, but you have to be able to detect it fast, because if you have a problem, if this is clogged for whatever reason, you need to know where it is, you have to be able to get to it, and you have to clean it. Same with the overflow. This is a really creative inflow in Ballard, actually. So we can talk a little bit about the Ballard rain gardens too, probably. This is another really nice inflow. You can see the metal coming in from the dam spot. And the overflow is right here with the rocks. These are not very big structures, and they gather usually water from about 2,500 square